Hello, Math 7 students, and welcome to our sixth video. So we're going to turn to our table of contents. The sixth video for today is unit rate as the constant of proportionality, and that can be found on page 19 in my comp book. So I'm going to turn to page 19. Oops, I turned too far. Here's page 19, okay? And basically, what we're going to be looking at or working on today is unit rate as a constant of proportionality. Today, we are going to learn about the constant of proportionality. Question: what is another name for the constant in a proportional relationship? We're going to learn another name, okay? Just like Mrs. Nelson has several names. I have Mrs. Nelson, I have Mom, I have Aaron, I have wife, all of that kind of stuff. So that's another name for me. Well, today we are going to learn another name for the word constant, okay? So what is another name for the constant in a proportional relationship? That's what you're looking for in our lesson today. Our task that we're going to be working on to figure this out is wildlife scientists are studying the population of deer per square mile in our forest. In a 16 square mile area, there are 144 deer. In a 13 square mile area, there are 117 deer. In a 24 square mile area, there are 216 deer. Do you think that the deer population is in danger? Now, you guys are probably going, I don't really care. Well, you should, okay? First of all, there is this opportunity that children get to go hunting, and if the deer population is not high, then you won't be able to hunt. So if you're a hunter, it does affect you big time. So we need to figure out if it's a proportional relationship or not. So basically what we're going to do that is we're going to build a ratio table and a graph to see what we can learn. First thing that I would like you to do is you need to fill out your ratio table. And what we need to do to figure out that is what depends on what. So I would say that the deer depend on the total mileage of area to live. So you're going to say that the independent variable is the square miles and the dependent variable is the number of deer. So you're going to put that on your ratio table right here. So I need everybody to write square miles up here. Okay, and then I need everybody to write deer right here because the deer rely on the land in order to live. And now let's go back into our story again and read it and see what we learned. So it says in a 16 square mile area, there are 144 deer. So you're going to put 16 under square mile and you're going to put 144 on under the deer. Okay, in a 13 square mile, we see that there's 117 deer, and on a 24 square mile, there are 216 deer, okay? And now, I know it's all over the place, but we can still organize that in order to help us understand what it is and what we need to do, okay? So we have it on our ratio table, and then we need to do a graph, okay? So let's build a graph knowing that square miles is our x-axis. Number of deer is our y-axis. Okay, and then what we're going to do is we're going to plot them to see what we learned. What are the three things that we know if a relationship is proportional? What do they have to have? Has to start at the origin, that's right. So if we have 0 square miles of land, that means that there are 0 deer. And that is correct. If they don't have anywhere to live, then there can't be any of them, okay? And then it has to be a straight line, and then it has to have a constant. So we are going to work on that by plotting them. So the first one that we're going to plot is 0, 0, and that goes right here. Okay, now, looking at these numbers right here, what do you think would be the best way to draw our square mileage? And I would say let's count by 4s. How about? So we say this one is 4, 8, 12, 4 is 1, 2, 3, 16, 20, 24, and that gives us our highest one that we have to worry about over here. Then we're going to come over here, and what do you think that we should count by on this one? Well, we have a spread from 100 to 200, so maybe by 50s, that might work. So let's do 50, 100, 150, 200, 250. Okay, so that's probably high enough. All right, so 0, 0, we put our dot. That's already there. 16 to 144. So if we go over here to 16, we're going to go up to 144, which has to be somewhere between 100 and 150. So let's say that it's about there. Okay. And then 13 is in between 12 and 16, so it's a little bit after 12, and they say it's 117, so we're going to say it's about there, right? And then 24 is out here, and it says 216, so we're going to say that it is about here, okay? And then what we have to do is we have to see if that looks like it's a proportional relationship. So we're going to connect our dots as close as we can, right? See what we can do. Straight line. And remember, if it was exactly drawn on graph paper, it would probably look pretty similar to that. Is there another way that we could check to see if there's a constant? Everybody, how do we do that? Do you remember? That's right. You have to figure out how you got from 16 to 144. So in order to figure that out, we know that 16 times something equals 144. So in order to do that, you have to take 144 and divide it by 16, okay? So I'm going to take 16. 16 can't go into 1, can't go into 14, so now we have to figure out what it would do to get into 144. So I'm going to just guess, and let's try 8, see what happens. So 8 times 6 is 48. Regroup the 4, so that is 128. Close. Let's see if we can get any closer. How about times 9? That's 54, 5, 9, 10, 11, 12, 13, 14. Oh, check it out. That's 9. So we know that 16 times 9 equals 144. Well, let's check 13. What is 13 times in order to get 117? Well, let's try 9 just to check. So we're going to do 13 times 9, and you get 27. Regroup the 2. 9, 10, 11. Boom, done. Found it. Yes. Okay, let's try the last one. So 24 times something gives me an answer of 216. How many of you just want to try 9 to see if it's that easy? Let's try it. 9. 4 times 9 is 36. Regroup the 3. 9 times 2 is 18. 19, 20, 21. What did we find? Ta-da! So does it have a constant? How many times did we multiply everything by? We multiplied it by 9. So does it have a constant? And the answer is yes. So let's do our little check sheet really quick. Did it go through the origin? The answer is yes. Was it a straight line? The answer is yes. And then the last one is, does it have a constant? And the answer is yes. So we just determined that this is a proportional relationship. So boys and girls, let's look at the question again. It says, wildlife scientists are studying the population of the deer per square mile in our forest. In 16 square mile area, there were 144. In a 13 square mile area, there were 117. In a 24 mile square area, there were 216. Do you think the deer population is in danger? Well, what we learned, if we continue this down, could we figure out how many deer would be in 1 square mile? And we can, because basically what we're doing with that, if you go back to my work, how do you get from 16 to 1? That's right, you divide by 16. And then what you do to one side, you have to do the other, which we already did. We did that right here, yes, to find the constant. 144 divided by 16 equals 9. So in 1 square mile, there are 9 deer. So if you're a hunter and you're trying to hunt deer for dinner and you just look in 1 square mile, how many deer at least will be there? 9. So do you think that there is a deer population problem? Probably not if there are 9 in every square mile, okay? Do you see how making a ratio table and a graph really helped us visualize and be able to answer that problem, okay? And believe it or not, scientists really do this, kiddos. They do this math in order to figure things out and to help things. So it is important to know how to do this. All right, let's turn the page and keep going. All right, so what we learned from that little experiment is, put your title on the next page if you're going to a next page like me, please. Ratio tables and graphs are made of independent and dependent variables. Independent variables are items that can exist without any other item. They are known as the X value. Dependent variables are items that only exist with the independent item. They are known as the Y value. Do you notice that if there wasn't any land for the deer to live on, the deer would not be alive? So we said that the deer depends on the land in order to live, so that's why the deer are the dependent and the land is the independent, because the land's going to be there whether there's deer or not. Okay, that's how you determine that. The constant, as a quick review, is the amount that is multiplied to the X value every single time. What did we multiply every single time? Look, 16 times 9, 13 times 9, 24 times 9. So it is the amount that is multiplied to the X value every time. Unit rate is determined by always dividing the Y value by the X value. Okay, so if we look at our ratio table again, here is our X value, here is our Y value. This was the deer, this was the land, okay? And in order to figure out, what did we do? We took 144, which was the Y, and we divided it by the land. We did it right there. We could take 117 and divide it by 13, and we would figure out that it was 9. Sorry for flip-flopping. We could take 216 and divide it by 24, and we would figure out, again, that it was 9. So, in order to find the unit rate always is the Y divided by the X. 144 divided by 16, 117 divided by 13, 216 divided by 24. And every time we did that, we got times 9, times 9, times 9. Okay? And so when we took that answer, we take 144 divided by 16, and we get 9. We took 117 divided by 13, we got 9. And we take 216 divided by 24, and we got 9. So what is the unit rate of this problem right here, kiddos? The unit rate is 9 for this problem, okay? So we know that the constant and the unit rate are the exact same thing. That is the most important thing that you can take away from this lesson. The constant and the unit rate are the exact same thing. So remember when we started this lesson, I told you we were going to find another name for constant? Everybody, what is another name for a constant? I hope you said unit rate, okay? So right here, this is what you have to answer for me. What is another name for the constant in a proportional relationship? And that's all that I'm going to have you do, okay? All righty, I'll see you in the morning.